Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So today is the physics day. So we are going to start physics from the second chapter. And the second chapter is about motion. What exactly is it? Let me. Yes, it is describing motion. So you see that whenever a thing is at rest, it is at rest. Okay, and when it start moving, it is in motion. Okay, it is a simple theory that anything which is moving is in motion. So there are some examples given to you in in the foreword of your book. So there's an example of around the world in 80 days. You might have seen the film, also the um, film on the cinema around the world in 80 days, and feature film. You can say the feature film, and also about you have seen the cartoons when you are at the lower stages. Around the world in 80 days is yes. Maybe in 80 days, someone has tried to go around the earth in 80 days. It is not very much difficult nowadays. Maybe we can even travel more faster. So, my dear students, in olden days, you know these facilities and these provisions were not there, like aeroplanes and supersonic jets uh, and cruise ships were not there. So only ships were there, jets were there, and camels were there, the ship of the deserts, and of course uh, on foot was also available there. But as I said you that it is not very much difficult to go around the world in 80 days nowadays. You can even travel within a week. So the radius, the diameter of the earth is how much? Yes, the circumference of the earth is 40,000 kilometers. The circumference. You know what is the circumference? I told you in the last chapter that is pi d. Okay, pi d or 2 pi r. The circumference, the perimeter of the earth is 40,000 kilometers. Okay, and you can travel 40,000 kilometers in just few days nowadays. So that was uh, just a four words for you, but we are going to start with the speed. What is speed? If I say you that to define what is speed, speed is the distance traveled by a body, the distance traveled by a body in unit time. You see that it is a scalar quantity. Now what is scalar quantity and what is vector quantity? Let me explain it to you first. Now, what we are going to do is today motion, and exactly the name of your chapter is describing motion. Describing describing motion, and in describing motion, we have taken speed at very first topic. Okay, now uh, is the speed is the distance traveled, is the distance traveled by a body, traveled by a body in unit time. Okay, or s is equal to speed s is equal to, you can say s is equal to speed is equal to, it is distance traveled by time, d divided by t, d divided by t. So what I was telling you about, this is a scalar quantity. This is a scalar quantity. Now, what is a scalar quantity? We might be studying in our later chapters that what is a scalar chapter, what is a scalar quantity, and what is a vector quantity. Now, scalar quantity is the quantity in which only the magnitude is given. The scalar quantity is the quantity in which only the magnitude is given. Magnitude is taken. Okay, scalar quantity is the quantity in which the for example, on the Richter scale, you can say when the earth shakes, when the earth shakes, tremors, earthquakes. Okay, then we say that it was 6.8 in magnitude at the Richter scale. Okay, it was 6.8. Now this 6.8 does not tells us in what direction it did happen. In what direction it did happen? 6.8. Okay. Now, if I am going, so what is scalar? Scalar is only magnitude, and if the other thing, which is a vector quantity, we say a vector quantity, it has both magnitude and direction, both magnitude and direction, and the similar thing to speed. The similar thing to speed is velocity. I'll be studying this. I'll be touching this velocity in my next, maybe somewhere in the or velocity. Now, what is velocity? Velocity is the speed in the stated direction. It is the speed in stated direction, and what we can say it in these words. It is the distance traveled by a body in unit time to the particular direction. In the particular direction, we have to add these 3 to 4 words in the speed, then the speed will become the velocity. It is the distance traveled by a body or an object in a unit time. Nothing. This is nothing. Speed. It is only magnitude. When it is only magnitude, it is the distance traveled by a body in unit time. And when we say in a particular direction, in a particular direction, in a particular direction, so it will be called velocity. So velocity is not here in your course. It is beyond your course today, but I'll be touching it. So far, this thing we are not studying, we are studying speed. It is the distance traveled by a body in unit time. Now, if I am going, now you see that when you are traveling on motorway M2, M1, M2, whatsoever, are you on, uh, you are going on motorway M2. You are going on motorway M2 from Islamabad to Lahore, you see that there are many cameras for your surveillance, and to monitor you, and to monitor you, there are many cameras. At what speed are you going to? At what speed are you going to? For example, if you are at 120 miles or 120 kilometers per hour, it is okay for you if you are on the car, or if you are on the light vehicle, LTV. Okay, if you are on the light vehicle, on the car or on the jeep or whatsoever it is, that the limit of the speed is 120 kilometers per hour. If you are going to 120 kilometers per hour, no one is going to ask you why are you going to at 120 kilometers per hour. But if you crosses the limit plus the tolerance, the tolerance at M2 is plus 9 kilometer, is plus 9 kilometers per hour. Okay, if you cross this limit per hour, then the surveillance cameras are looking at you, and sometimes the staff also take the camera with them to watch your speed. They are on M2 at places. They are standing at places, and if you are above 129, or let us say that if you are at 132, then you are stopped there. You are stopped there by the surveillance team or by the monitoring team, and at the end you have to pay an additional challan, or you have to pay. You are penalized uh, you are penalized by some amount uh, which you have to pay there, and then you are allowed to pass from the M2. So uh, the main reason is to tell you that the surveillance camera are looking at your speed. The surveillance camera are looking at your speed, no matter what is their procedure, what is their time, what is their limit, whatsoever is. They are looking at your speed, and even if you are going at 70 kilometers per hour, then you are again obstructing the traffic there. You are obstructing the traffic there. You are too slow, and you are obstructing the traffic. So you are again being monitored by the camera. So it means that this is the speed. It means it is the speed at which you are going. But if I say you are going at the speed to Lahore, then it is velocity. Okay, you might have understood my point. So let me proceed now. As I've told you about the speed, now distance, time, and speed. Now what is distance, and what is time, and what is speed? Distance, time, and speed. So the distance is, for example, I just told you that from motorway toll plaza Islamabad, okay, toll plaza Islamabad to toll plaza Lahore is the 2 points, are the 2 points A and B. Now this is the total distance. This is the total distance. Okay, this is the total distance, which is about, I think it is 333 kilometers. It is 333 kilometers. Okay, from Islamabad to Lahore, the distance is 333 kilometers. And what is time? The time taken by you, the time taken to travel from point A to point B is the time. The time taken to travel. For example, you are going at the steady speed. You are going at the steady speed of 100 kilometers per hour. At 100 kilometers per hour, maybe then you will cross these 2 points from A point to B point. You will cross in 3 hour and 30 minutes. 3 hours and 30 minutes. Uh, Plus minus something. Okay, plus minus something. Okay, now if you are traveling at 100 kilometers per hour and your speed is 100 kilometers, now the time is 3 hours 30 minutes, and the speed is 100 kilometers per hour. Now what, what if you are staying at Bhera? This is a stopover almost in the middle of the 2 points. Almost in the middle of the 2 point, it is Bhera. So when you go from A to Bhera and rest here for 20 minutes, and then again start your journey from Bhera to Lahore, that means you have broke your distance into two parts. You have broken your distance into two parts from Islamabad to Bhera and Bhera to Lahore. You have broken this journey into two parts. Here you have rested, you have taken some snacks and whatsoever you have done it. You have taken tea or coffee, and then you have started from here to here. Now your steady speed, will be the average speed, because you have taken two steps. Now here is one step and the other is the one step. Now this will be the average speed. What will be this? Will be the average speed. Average speed will be the total time taken, total time, total distance traveled, total distance traveled, total distance traveled divided by total time taken. Total time taken. So this is the average speed, because you have stayed here, you have taken rest over here, but you know your clock is going on, your clock is just ticking on, your clock is just ticking on, because from home you have, for example, just this is your home, you just uh, don't mention this time, just take this time to this time, then you have traveled from here to here and here to here, your time is consuming, however your time is consuming, therefore the total distance traveled is equal to the total time taken is the average speed, is the average speed. Now let me take another example. For example, if you are traveling 10 meters in 1 second, now you see it is unit 1 second only, it is 1 minute, okay, 10 meters in 1 second, 20 meters in 2 seconds, 10 meters in 2 seconds. Now this is 2 seconds, and 30 meters in 3 seconds. Now you can write it here in 2 seconds and in 3 seconds. Now you see that your speed is very steady over here. Your speed is very steady over here, and you are traveling at the speed of 10 meters per second, because after taking each second, you are ahead 10 meters. Now here, after 1 second, you are again 10 meters ahead. So you are traveling at the speed of 10 meters per second. Now for another example. Now there is a race, cycle race, or you see, I told you about the sprint in the last lecture, but now the cycle race. If you are going at the cycle race, for example, your cycle race is, let me say that 400 meters is only 400 meters. Now this counts. Now this counts because it is only 400 meters. The time will be taken on the stopwatch. On the stopwatch, okay. The time will be taken on the stopwatch. But if the same cycle has to run a marathon, which is about 26 kilometers, it is about 26 kilometers. Then maybe 1 or 2 seconds will not count. Will be not count. 1 or 2 seconds will be not counted. Okay, if it is a marathon race. Now I am going to show you the table in which I am going to show you quantities and their respective units in SI units, Standard International, MCAS units, and in foot pound system. Okay. Now let me make this table first. Now this is the table. In this table it is quantity, and then the units SI, and then the standard units, other units are MCAS units. Let me do it other units. These are the other units. And in these other units, there are uh, FPS system. Okay. Now, FPS system is nowadays not very much used, but even then we have to know these things. Okay. Now, there are three quantities: 1, 2, 3. First one is distance. Okay. Time and speed. Time and speed. Now in distance, the SI unit is meter, which is known as m. Meter. Okay. Distance, which is measured in meters, and in MCAS system it is in kilometers. And it is written in km, capital K and small m. Okay. And in FPS system it is miles. miles, miles, m, only m. Okay, meter, SI units, kilometer. You can, yes, this is in CGS also. Okay, but it is the amalgam of CGS and MCAS system, SI units. Okay, kilometers, km, and miles, m only, FPS system. In times, it is second. Yes, I told you in this very first chapter that it is hours and it is again hours. Okay, speed, speed is taken in meters per second, meter per second. Now this is you. I told you speed. What is speed? It is d upon t. It is d upon t. Or you can easily make this whenever there are three quantities. Whenever there are three quantities, you can uh, take this triangle to find which quantity do you need. Now, since I need d upon t, this is d upon t, this is s d upon t. S is equal to d upon t. Okay, s is equal to d upon t, so it will be meters per second. Meters per second. It is meters per second. If in MCAS, it is kilometers per hour, because d upon t, d upon t, and d upon t is mph. mph is miles per hour. It is miles per hour, kilometer per hour, meter per second. This is the speed. Now you can easily find your relatable unit from here. It is standard international unit, meter, kilogram, and seconds, and in FPS it is foot, pounds, and second. Okay, now let me proceed to the example. Now a numerical is given as your example. In physics, I have told you the questions which are mathematical are called numerical questions. We are almost finishing this chapter today, and in the next chapter, maybe we be doing some questions. Yes. Okay. Now there is worked example, and it is 2.1. Now, what is the example? A cyclist completed 1500 meters. Okay. Now, what is the distance? Always write the data which is provided to you, which is given to you in data form. Now, this is 1500 meters. And always look at very fast type, always look for the units, what you have been provided with. What you have been provided with. Okay. Now, it is 1500 meters stage of race in 37.5 seconds. What was her average speed? Now, what is the time? Race in time. T. Time is equal to 37.5 seconds. Now, you see that no problem with the units. It is SI units. I have just told you in SI units it is meter and second. Okay, it is meters and second. This is distance and this is time. Okay, now what we have to find is we have to find what was her speed. The cyclist is female, of course, and what was her speed? Now the speed is we have to find the speed. We have to find the speed that is unknown to us. We have to find the speed which is unknown to us. Now, the formula for speed, I have already told you that speed is equal to distance divided by time. And this implies that what is the distance? Distance is 1500 meters. Always write the unit long way. Always write the units. Okay, always write the unit. It will be easy to judge you what will be the unit of what we are going to discover, or what we are going to explore, or what we are going to calculate. Okay, now you see that this is speed. We are going to find the speed. So speed is in meters per second. It is in meters per second, meters per second. So it should come in meters per second. Meters divided by seconds. Now time is given in seconds, so it is nothing problem with this. Meters per second should be our answer. Should be the answer of the units. Now this unit is correct. Okay. Now this unit is correct. Nothing to do with this. So it will be when it will be calculated. It will become. Now let me calculate it. It is 1500 meters. Let it is 1500 meters. Now divided by 37.5, it will become 40. So it is 40. And the these are also given. So 40 meters per second is your speed. 40 meters per second is was the very simple numerical. So very simply it has been done to you. Now there are other questions, and we are going to do these questions also. What is the Usain Bolt's average speed? Usain Bolt's average speed when he achieved 100-meter record in 9.5 seconds in 2009. Now, in the last exercise, or in the last lecture, or maybe in the first lecture, no, not the last. In the first lecture, I told you the Usain Bolt uh, uh, hit the world record in 2009 in the sprint, and achieved the fastest man of the world, fastest man of the world, and it was 9.5 seconds, which he traveled 100 meters. 100 meters. Took 9.5 seconds to run 100-meter sprint. Okay. It was in fact very precisely it was 9.58 seconds. 9.58 seconds. Okay. So in what was Usain's average speed when he achieved in his? How do you know that his top speed must have been higher than this 100 meters? Yes. So the distance was 100 meters, and the time on the stopwatch, digital stopwatch, was taken as 9.58 seconds. Now we have to take. Now this is not the unit, because unit is only 1 second. Okay, unit is only 1 second. So if we want to take the speed at which we was traveling, it will be 100 divided by 100 meters divided by 9.58 seconds. Okay, then we will have this unit. Okay, now what is 100 divided by 100 divided by 9.58? It will be this, and it will be this. So it is equal to, the speed was 10.44 almost. This is 438 meters per second. Meters per second. So it would the uh, speed of Usain Bolt was 10.44 meter per second. Okay. Now, how do you know that his top speed must have been higher than this? Because this was the question number A, and the question number 3B is theoretical, because this is 10.44 meter per second, and he might have gone up to maybe 11, or maybe to 11.5 meters per second at some strides, and maybe he might have gone to 9 meters per second at some strides. So the average strides were 10.44 meters per second, and the total time taken by him was 9.5. Maybe he have taken 11 to 11.5, and from 9 to 11.5 maybe. Okay. Now question number 2. A cheetah runs 100 meter in 3.11 seconds. What is it? Same question is there. Same question. It is the same question. Now cheetah is running at how much speed? We have to know it. He runs, what is the distance? Now this is question number 3, question number 2. Now question number 2. on page number 21. It is, how do you note that a cheetah runs 100 meters? Now distance is 100 meters. Very simple questions, and time taken by him by it. Okay, for animals we take it 8. Cheetah runs is, it is 3.11 seconds. Okay, and now speed is, what is speed? Speed is distance divided by time. You can just divide, because the units are same, so there is no problem, and the answer will become, let me do it. The speed is equal to 32.15 meters per second. 32 meters per 32.15, 3 times of Usain Bolt's. Okay, 3 times it is, if that is compared to Usain Bolt's 32.15 meters per second. So question number 3. Question number 3. Let me complete the question number 3, and then I'll tell you information about 3 train traveling between stations is shown in table 2.2. Now this is table 2.2, which I am going to reproduce in front of you on the whiteboard. Okay, on the whiteboard. So what is it? It is vehicles. Vehicles. Okay. Distance traveled in kilometer. Distance traveled in kilometers. Okay. Now this is traveled in kilometer. Let me write it very clearly that it is in kilometers. Kilometers. And time taken in minutes. Now this is the time taken. So this is time taken minutes. minutes. Okay, close this boundary now. Grid. And what is the data? Train A, B, C. Now this is train A. Okay, draw a line. B, draw a line. C, draw a line. Train A, train B, and train C. Now the distance here is given 250 kilometers, because once it is read, need not to write again and again. Okay, it is 72 and it is 400. Now these are the distance traveled, already traveled, for 200, 250, 72 kilometers and 400 by each. The respective distances are written against each of the trains. Train A 250, train B, and so on and so forth. And time taken is 120 minutes. 120 minutes. Again, the minutes is mentioned over here, need not to write. 50 and 150 minutes. Now, my dear students, you see that when nothing is given to you, then you may calculate it in SI units. This is the easiest of all. You can calculate in MKS also, but it is easy to calculate it in SI units. Now for SI units, you know that in SI units the your uh, speed is your speed is calculated in meters per second. Okay, meters per second. Now what is this? This is kilometer, this is minutes. This is kilometer, this is minutes. You can directly do it, but to be more precise, you should have to calculate it into meters per second. Okay, now meters per second. Now from kilometers, when you go from kilometers to meters, from kilometers to meters, you have to divide the quantity, you have to multiply the quantity with 1000. You have to multiply the quantity with 1000, because there are 1000 meters in 1 kilometer. So by multiplying it with 1000, by multiplying it with 1000, by multiplying it with 1000, what we get here is 250 was already there. So put 3 zeros more. Okay, 250,000. This will become 72,000, and this will become 400,000. These are what meters now. Now these are meters. You can also write it meters. And since this is in seconds and this is in minutes, multiply it with 60 to get it in seconds. To get it in seconds. What will it become? Two zeros and 7,200. 7,200 seconds. 7,200 seconds. This will become 0,0653 30. 3,000 seconds, and for this it is 90 and 00. 9,000 seconds. Okay, it is 9,000 seconds. Better check it also. 120 multiplied 60 equals, okay, these are all correct. Now what we have to find is which train has the highest average speed. Now we have to find the average speed of all. Now let me clear this thing over from here. So we have to find the this is distance, this is time, and what is distance divided by time? Meter per second is speed. Yes, it is also written over here. Speed is meters per second. So meters, here the meters are 20, 200, 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. 250,000 meters divided by meters per second, 7,200. Now two zeros will be struck off with this, and we are left with 25 divided by 2,500 divided by 2,500 divided by 72. It will become 34.72. 34.72 meters per second. Now this is its average speed. Now I can also add one more column to it. Okay, average speed. Average speed. Average speed is 34.72, and for this divided by this again. Okay, it is 72,000 divided by 3,000. These three will be struck off, and it will become 3 2 times and 3 4 times. 24 meters per second. Okay, 24 meters per second. It is 72,000. Yes, it is 72,000 divided by 3,024. Okay, it is good. Now for this, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 400,000. That means divided by 9,000. Stuck these three, and then the remaining part you divide it on the calculator. It will become 44 point, say 5, because it is 44.44. I have just taken it 5 meters per second. 44.5 meters per second, because taking it as 5, it doesn't affect these two. Okay, now what is asked? Which train has the highest average speed? Now you see that this train has the highest average speed. Highest average speed is train number C. Which train has the lowest average speed? Yes, this train has the lowest average speed. Lowest average speed, because this is 24, this is 44, and any other? No, there are only two questions about this. Now, uh, I hope you would have understood this, so I can erase this. I am going to just touch the next topic, just touch, because this topic is determining the speed in lab. So there are two dipoles sort of things. These are dipoles, and maybe these are the uh, what is these? Yes, these are infrared beams. Now this is infrared beam from here to here, infrared. Now let me do it in red color. I do have it. Now these are the beam. Now when a body will travel from here, will is coming from behind. Okay, it's coming from this side. When it will pass this, the time will be noted here, and this distance is already calculated. This is d, and you see that when it will come over here and strike this beam, the time will again be noted. So your speed, in other words, can be noted from this experiment. So my dear students, you can do it now. But nowadays, the same procedure is done with a laser gun. With a laser gun, you might have uh, seen it in the cricket and on the motorways. Cricket, when the bowler ball, when the ball uh, throws the ball from the bowling pitch. Now this is the bowling pitch. This is the bowling pitch. He throws the ball from here, and the ball comes over here by any means, by like this or so, whatsoever it is. Then this is taken in the laser gun, which is outside the boundary, outside the boundary, outside the boundary. So this is taken in the laser gun, and the moment it left your hand, the moment it left the hand of the bowler, and the moment it strikes the bat or whatsoever, strikes the wicket, or you can say the moment it drops on the ground, that the laser reads it and calculate it automatically and get the speed of your ball. Okay, get the speed of the ball. And on motorway, the staff is sitting, and he just has a camera which is laser operated, and he just take your speed like this in 2 instants, and he just managed to get your speed whatsoever your speed is. Okay, so let me proceed now. So my dear students, the last of our is, what is this? S is equal to Vt. We want to rearrange our equation. Rearranging equation is equal to speed is equal to, okay, S is equal to, speed is equal to distance divided by time. Now we'll be using the abbreviations for each of the following. So time is t, okay, no problem with time, and S is the distance, and S is the distance, and V is the speed. Okay, V is the speed. V is the abbreviation which is used for speed. So it will become S is equal to Vt. S is equal to Vt. Now you can also do it like this, whenever S is equal to Vt. Now you see S is equal to Vt, T is equal to S upon V, V is equal to S upon T. Because here it is speed, it is S upon T. When you want to find T, it is S upon V, and when you want to find D, it is when you want to find V, it is S upon T. Okay, so this is the equation. V is equal to S upon T. V is equal to S upon T, or S is equal to, it is equal to distance into speed into time. Distance is equal to speed multiplied by time. Distance is equal to speed multiplied by time. Hope students that you would have understood S is equal to Vt very well, because sometimes we have to, in the earlier stage I told you that uh, distance, that speed is equal to, distance divided by, now these were my own abbreviations. Okay, these are my own abbreviations, but since we have to follow the standard equations, so we have changed all and rearranged the distance and speed with the new, you can say, with the new or standard abbreviations. Now distance is equal to, now this will be set S, the T will be remain T, and V will be like this. So when you manipulate with this, it will become S is equal to Vt. Okay, got my point? We have to use the standard things. These are the standard. For earlier, I told you to let you understand only. Now, question number, what is the last worked example 2.2? 2.2 is our worked example, and earth, there's earth given over here. Okay, and you know the let me read it. A spacecraft is orbiting the earth at a steady speed of 8 kilometers per second. Okay, how long will it take to complete a single orbit of 44,000? Now this is, my dear students, you might be hearing some noises. Don't worry about these noises. Okay, so just emphasize on the board. Okay, now this is earth, and you know the circumference of the earth is 40,000 kilometers. 40,000 kilometers, the circumference, this, the boundary of the earth is, if it is, if you can say perimeter or circumference, the better word is circumference. Okay, which is pi d, or that is equal to 2 pi r also. Both are correct. Okay, both are correct. Pi d or 2 pi r. Now what is it? A spacecraft. Now a spacecraft is orbiting this. A spacecraft is orbiting. Okay, now this is a spacecraft. It is made like this over here, and it has been asked, but let me, at a steady speed. Now speed, V is equal to 8 meters per second. 8 kilometers per second. Yes, 8 kilometers per second. This is also called the escape velocity. What is it called? Escape velocity. Let me tell you what is the escape velocity. Escape velocity is the minimum velocity from which we can leave the earth to the space. From which we can leave the earth to the space. Suppose this is the earth, this is your earth, and you want to shoot to the you want to nullify the gravity, you have to go to 8 kilometers per second, at the speed of 8 kilometers per second. Otherwise you cannot cross the gravitational pull of the earth. Otherwise you cannot beat the gravitational pull at this. Okay, you have to maintain minimum of 8 kilometers per second. Okay, so this is 8 kilometer per second. the radius, the circumference of Earth is 40,000 kilometer, but the question is asked, how long will it take to complete a single orbit, a distance of. Now distance is equal to how much? 44,000. Now why is this 44,000 given? This is 40,000 because it is away from the Earth. It is away from the Earth. When it is away from the Earth, obviously the circumference will increase. Obviously the circumference will increase. So it doesn't matter. It is 44,000. We are asked to find at the 44,000. So we just manipulate, and what we have to find is how long it will take. Yes, we have to find time. Okay, Zahid, of course, we have to find it in the seconds. Okay, now if it is only 40,000, so it is very easy to find it at 40,000. P is equal to, just I told you about this. You can, S is equal to VT. What we have to find is T, S upon V, S upon V. Okay, it is very easy to manipulate like this. On a triangle, draw a T, S is equal to VT. We have to find T, T, S upon V, S upon V. T is equal to S upon V. If it is on Earth, will be 40,000 divided by how much? 8. Okay. This is kilometers, this is seconds. Okay, when you do it, it will become 8 5 times 45,000 seconds are there at Earth here. But we have to find it here. We have to find it here, not here. So it will become 44,000. Same, apply same rule over here. 44,000 divided by 8, it will become 5 and again 5 and then two zeros. It will become 5,500 seconds. You can convert it into, yes, you can convert it into minutes and also in hours. If you divide it with 60, it will become almost 92 minutes, and 92 minutes is 1 hour and 32 minutes. So, my dear students, you might have noticed that the kilometers, the units over here are from the same unit. The units are from the same unit, so we need not to convert these, because this is kilometer, this is kilometer. And if we would have changed into meters per second, because this is in kilometers, so it will become like this, 44,000, and this is kilometers, so just add 3 more zero. Okay, then it will become, and this is 8 kilometers per second, so it will become 8,000 meters per second. The answer will be same. We have, in simple words, we have added 3 zeros here and 3 zeros here. So it is nothing doing with 3 zeros in denominator and equal amount of zeros in the denominator. So it will make no difference in the answers. So my dear students, it's time to say you goodbye. Allah Hafiz, and see you in the next chapter, in the next lecture about in the numericals, in the numerical session. So it's time to say you goodbye. Keep watching my physics channel also. Allah Hafiz.